Hey everyone, welcome back. Ready to dive into something pretty mind-blowing today.
Always up for that. What are we tackling this time?
Well, we hear a lot about AI these days, right? But how do we actually make sure these super smart systems we're building are, well, actually smart?
Right, right. You're talking about the whole issue of AI hallucinating, making stuff up.
That's part of it. And it's a big challenge. We're diving into retrieval augmented generation, or RAG, today.
RAG, okay. Making AI smarter. I'm intrigued.
So we've got this research paper, knowledge graph versus vector database, which one to choose. It's all about how we can use external data to make AI more reliable.
So instead of letting the AI just riff freely, we give it some solid information to work with.
Exactly. Imagine instead of just handing someone a microphone and hoping for the best, you give them access to a whole library of information. That's RAG in a nutshell.
Makes sense. But isn't there like tons of data out there that's not exactly organized for AI? Emails, research papers, all that stuff.
You're spot on. A huge amount of data is unstructured, and that's where knowledge graphs and vector databases come in. Two very different approaches to organizing and accessing this messy data.
Okay, so two sides of the same coin, kind of.
In a way, think of a knowledge graph like a detective's evidence board, with all the strings and photos connected. Each piece of information is an entity linked by relationships.
Interesting. So if you were researching a new drug, for example, a knowledge graph could connect the drug itself to the researchers who developed it, the clinical trials, maybe even patient testimonials, all linked together.
Precisely. You see the full picture, not just isolated bits and pieces.
That makes sense. But I imagine building these knowledge graphs is no easy feat, right?
You're right. It takes a lot of effort up front to define all those entities and relationships.
Kind of like meticulously building a giant, intricate model, right?
Exactly. But that structure is what makes them so powerful for complex questions, like having a well-organized library with a detailed catalog.
Gotcha. But then what about these vector databases? They sound way more, I don't know, mysterious.
A bit more free-flowing, maybe. Think of vector databases like, how about this? Instead of meticulously cataloging every single book, you group them based on their vibe. Similar themes, writing styles, even emotional tones.
So it's less about deeply understanding the content and more about finding things that feel similar.
Exactly. And that's incredibly powerful when you're dealing with massive amounts of data. Let's say you want to find articles related to, I don't know, a new scientific discovery. A vector database could uncover relevant research, even if the authors use totally different terminology.
Because it's detecting the underlying meaning, the connections between the concepts, not just the exact words.
You got it. So we've got knowledge graphs, great at precision and complex connections.
And vector databases, the masters of finding patterns in massive data sets.
But of course, there's always a trade-off, right? There has to be.
Right, trade-offs, always trade-offs.
Yeah.
What do we give up with these vector databases?
Well, it seems like while they're incredibly good at finding these similarities, they might miss some of the nuance, the deeper relationships that a knowledge graph could capture.
Okay, I see what you mean. So less about the whole story, more about finding those echoes.
Yeah, something like that. Imagine, let's say you're researching a company, trying to track down some info about a specific product launch.
Okay, yeah, I'm with you.
A vector database might be able to find articles mentioning the product, maybe even some stuff about their stock price around that same time.
But it wouldn't be able to tell you if the launch actually impacted the stock price.
Exactly. It might show you the two pieces of information exist, but not necessarily connect the dots for you.
Interesting. So it's kind of a double-edged sword then. And I imagine this reliance on similarity could lead to, well, some inaccuracies, right?
Definitely a risk. Think
Well,
about, let's say you're looking up information about a medical procedure.
okay, kind of a critical one to get right.
Right. A vector database might accidentally point you to articles about a similar procedure, but, something with way more risks involved just because they share a lot of the same medical terms. Not exactly ideal.
Yeah, not ideal at all. So it sounds like both of these approaches, knowledge graphs and vector databases, they each have their own strengths and weaknesses. How do you know which one is right for the job?
Well, according to this research, it all comes down to what you're trying to achieve, what kind of questions you're asking.
Right, horses for courses, as they say.
Exactly. The article actually has this really handy table comparing the two across different factors. Like if you need that absolute accuracy, that ability to handle those really intricate relationships, a knowledge graph is probably your best bet.
Makes sense. The more complex the connections, the more you need that structure.
But if you're dealing with just a mountain of data, unstructured data, and you need to pull out insights, maybe uncover some patterns based on similarity.
Then a vector database might be the way to go.
Exactly. Kind of like choosing between a scalpel and a microscope. Both essential tools.
But for totally different jobs. Love that analogy.
Uh-huh.
But here's a question, and maybe this is getting a bit ahead of ourselves.
Yeah.
What if you didn't have to choose?
Oh, now you're talking. Combine the power of both. Tell me more.
Well, imagine this. You take that structure, that logic of a knowledge graph, and you use it to bring context to a vector database's pattern recognition.
Okay, so it's like enhancing the vector database's strengths with the knowledge graph strengths.
Exactly. It's like having, I don't know, a master detective with a photographic memory.
Okay, now that's an image. How would this play out in real life, though? Give me an example.
Sure, sure. Let's say you're building a platform, one of those sites that connects businesses with potential investors. A vector database could analyze tons of company profiles, investor portfolios.
Looking for those initial matches.
Yeah, based on things like, industry focus, investment stage, all of that.
Yeah.
But how do you make sure those matches are actually promising, not just surface level? That's where the knowledge graph comes in.
Ah, I see where you're going with this. To dig a little deeper?
Exactly. It could analyze the relationships between people at the company, their track records, even market trends, just to see if the match actually makes sense long term.
So you're moving beyond simple pattern recognition to a deeper understanding of the whole picture. Risks, rewards, the works. That's incredible.
And honestly, we're just scratching the surface here. This combined approach could be huge for all sorts of fields, from scientific research to education. Think about it, an AI tutor that could tailor lessons to your learning style and anticipate your questions.
Wow. That's a whole other level of personalized learning. But this all sounds so incredibly complex to actually build. Are there even systems in place that can handle this kind of integration? Or are we talking about some far-off future here?
It's definitely a challenge, for sure. This article actually talks about some of the difficulties of getting these two approaches to work together.
Like what kind of difficulties?
Well, for one thing, they often use completely different ways of communicating and processing data. Trying to keep everything in sync between the two can feel like,
Herding cats.
yeah, herding cats. Not easy.
Good.
But thankfully, it seems like some really smart people are already working on solutions.
Well, thank goodness for that. What kind of solutions? Give me some hope here.
Okay, so this article, it actually talks about something called FalkorDB.
FalkorDB. Okay, I'm not familiar with that one. What is it?
It's basically this system that acts as a bridge, like a translator almost,
Yeah.
between knowledge graphs and vector databases.
Oh, interesting. So instead of having two separate systems that don't talk to each other, you've got this one platform that can handle both.
Exactly. You could store both types of data together, query them together. It's all seamless. It tackles all those integration headaches we were talking about, the data silos, the compatibility issues, all of that.
So no more herding cats. That's a relief. Tell me more about this FalkorDB. What makes it so special?
Well, for one thing, it's built for speed, which, when you're talking about AI applications that need to process tons of information, that's huge. And it can handle these massive data sets, no problem.
Okay, so it's fast, it's powerful. Anything else?
It's also designed to be much easier to manage than trying to keep separate knowledge graph and vector database systems in sync.
Ah, so it simplifies things on the back end, too. That's got to be a major win for developers. It sounds like FalkorDB could be a real game changer, honestly. For anyone who wants to dig deeper into this, where can they go?
The article links to the FalkorDB website. They've got documentation, tutorials, the whole 9 yards.
Awesome. We'll definitely include that in the show notes. Well, this has been an incredible deep dive. We started with AI making stuff up,
Went through detectives, Spotify recommendations.
the whole gamut. But really, it's amazing to consider that we might be entering a new era in AI. One where we can finally use all of this data, even the messy stuff, to answer those really complex questions.
It's pretty exciting to think about what breakthroughs are on the horizon.
Exactly. And that's something I want all of you listening to consider. What seemingly impossible questions could you answer? What could you achieve if you could connect all the dots in your own data? Something to think about. That's it for this deep dive, everyone. Until next time, keep exploring, keep asking those tough questions, and we'll catch you on the next episode.